All right, let's see. A soap bubble has an index of refraction of 1.34 and is 0.5 and is 504 nanometers thick. What wavelengths have constructive interference? What color is it? Right. Well, we're going to determine what color it is by determining where it falls in this wavelength thing. So I looked this up. This is from Wikipedia, right? And these are, red light would be that. So red is the big wavelength, violet light is the short wavelength, right? And so let's just figure this out. This is constructive interference, right? Okay, which of course would determine what color this soap bubble looks like, right? Okay, so let's see. Constructive interference is 2dn is m plus 1/2 lambda. It's got a plus 1/2 because we have to phase shift it by a half a wavelength because that first interface inverts the light. Okay, so we need to shift it at least a half a wavelength before we get constructive interference. That's why it's the 1/2 there. Okay, so this is 2dn. So this is our n. This is our d. We got to figure out the lambdas, right? Okay, so let's figure this out. Lambda is equal to 2dn over m plus 1/2. Is it that easy? It's that easy. Okay, so that's going to be 2 times the thickness is 504, and n is 1.34, and it's going to be m plus 1/2. All right, I think I can do this. Okay, I'm going to plug this in. You do such a good job. Okay, so 2 times 504 times 1.34 divided by 0.5. And I'm typing 0.5 so I can go back and change it to a 1, a 2, and a 3, and all that stuff. Okay. So the first wavelength, if m equals 0, and if I put a 0 in for that m, I get a wavelength of 2,701 nanometers. So let's see if that's a color. No, it's way bigger than 700, and 700 is like a deep dark red. You can barely see it, right? Okay, so that's not a color. All right, but let's make m 1. Remember, m can be any number, Okay, so let's plug a 1 in. Let me do this. So now I'm dividing the same thing. Only I'm dividing by 1. And if m is 1, then lambda is 900.48 nanometers, which is still bigger than 700. So that's like infrared. These you'd feel like heat, like a heat lamp, right? Okay, so let's try m is 2. So now I'm going to do this. M is 2. I'm plugging in a 2. I'm getting 540. I think that's a color. Let's look it up. Nanometers. Let's see. 540. Here it is. It's going to be this guy. In fact, it's right in the middle. It's going to be a very green, little green there. So it's going to be green. Okay. So that guy would look green, right? But let's see. Let's make m equal 3, right? Is that a visible wavelength? Let's try it. Because it might be a mixture of 2 different colors, right? And then that gets like beyond my pay grade. And then I'm getting lambda is 385.92. Notice that that's shorter than 400, so I don't think that we would be able to detect that with our eyes. Some insects would, though, right? I think some insects can see ultraviolet, right? So that's not a color. This guy is a color. So it's going to be this color, 540 nanometers. It's going to be green. Hoo-hoo! Hoo-hoo! Hoo-hoo!